Refresh. Right. Okay. Okay. Let's get. Okay. Before I start, why is it sounding weird? Excuse me. Yeah. Before I start, I'd like to say that got audio working finally. It was a lot easier than I thought it would be. Anyways, this is. Maybe I'll zoom in a bit more. Right. So I've introduced. So the audio. I mean, if you remember, I don't know if you do. Fuck! I thought this wasn't working. Yeah, the crackling is gone. And I can change frequencies. Okay, so that's good. Turns out the clicking noise was caused by the sine wave going to like 0 every time the next wave was playing. So every time the frame buffer was rendered, the audio was rendered as well, and then it would always start at 0. So let's say the sound wave was somewhere here, and then it going straight to 0 caused the clicking. So to fix that, very simple solution. Where is my game state? Here. I just added wave position to the game state, and yep, and then just increase the wave position in the game state. That's it, really. And then yeah, and now it works, which is, yeah, I'm quite pleased with that. And I mean, it took me like a week because I think it was Wednesday off stream. I tried all combinations of like buffer attributes. Excuse me. Yeah, and because I was convinced the problem was with my config. But yeah, thanks to Cloud, I was able to figure this out. Pretty easy fix in the end. I mean, it would have been faster if my debugger was working. It still isn't. Yeah, maybe I have to figure out how to use GDB. Maybe. Okay, so I think we're good to go ahead. Then I can skip the audio sync because audio lag and input lag. There is a lag. So for instance, Well, and the beginning is not great. I pressed A. I mean, that's pretty quick. You can ignore the bottom for now. No, it's not bad, really. It's quite fast. Not noticeable anyways. But I would like to see how Casey debugs this. And watch it a little bit.
That said, let us go and get started here. Someone on the chat was mentioning that we had an off by one error. Now we probably have a couple of bugs in what we were writing yesterday because we didn't really finish. We didn't get to the point where we really actually finished it up. We only just barely threw it in there. We threw in some rendering code. They were saying there was an off by one error with the debug time marker. I'm not sure exactly what they meant by that, actually, on the chat. If they want to go ahead and point out exactly what it actually is, then we can go ahead and look at it explicitly. But I'll take a quick look just to see if I see what they were talking about. We have debug time marker here. We advance it. I don't see an off by one error in the recording of it. It looks like it's going to record one each time, so that's good. Basically, we go in here, we use whatever the current value of debug time marker index is, we increment it by 1, which is fine in the case where we hit the array. There we go. That's what we were looking for. This should actually be like that. That actually needs to be checking for whether we hit the actual end of the array, so that was bug. Thank you for that. That is, again, one of those nasty little things. I don't usually make mistakes like that. I have to think that probably it is. I will admit my programming does degrade when I have to talk and explain stuff as we go. I think it takes up part of my brain, and it's a little harder for me to write bug-free code, which at the end of the day is okay because I suspect a lot of people watching this stream are beginner C programmers or intermediate C programmers, perhaps, and so possibly it's better for me to have to debug more stuff just so we can go through it. So let's see there. That would lead to a gap once in a while, but
that's the other thing. Yeah. That reminds me. I've got to fix my software rendering. Rendering. It's a difficult word to say. Where? Yeah. I'm thinking of having a two-dimensional array and then just casting it to a single-dimensional array. Or even just rendering it into a 2D array, and then I can just convert it. This is not easy to work with. You ever checked out the overgrowth devlogs? No, I mean, this is the first time I'm hearing of it. Yeah, I could do something about this. That's why instead of rectangles, it's like these diagonals. That's because it should be like, yeah. Jeez, that's wild. For 10 years. Let me see. Is it this one? It's also so in Steam. Okay. Here. I think this is it. Jeez, 14 years. That's a long time. We'll check it out after. Looks like a gaming studio. How you doing? What's the name? Haven't seen you in a while. Yeah, I'm gonna fix my renderer. Because the expected output, I was trying to make squares. Okay. Humble Bundle. Never heard of that either.
We were seeing too many gaps before, so it's looking pretty stable here anyway. This is roughly what we were expecting to see before, so we're good. Yeah, so all that is all.
Cheers. I'll have a look.
Good for now. Basically, what we need to do today is just decide how we're going to handle what decisions we're going to make based on the audio latency. So I'm going to go to the diagram for a minute and just talk about what we basically found yesterday. I should probably double mention, I guess, perhaps what that bug was, just in case people weren't clear. So before I accidentally had typed that whenever the debug time marker index is greater. So I'm going to go ahead and open up the infamous Microsoft Paint, Paint Program of Champions. And we're going to talk a little bit about what we learned yesterday, much to our chagrin, I should say. So we decided basically to start off with trying to hit 30 frames a second, right? And 30 frames a second translates into, right, you've got 1,000 milliseconds per frame in one frame, right? That makes sense. And so if we're doing 30 frames per second, 30 frames per second, right? Basically what we're expecting here is if we actually want to know how many milliseconds we're actually going to have in every frame, we would divide by 30, right? And so what ends up happening is we're expecting to see about 33.3 milliseconds every frame. That's how long we expect this.
Forgot to check that, really. Where's my FPS? Yeah, seems about right.
To take 33.3 milliseconds like that. That makes sense. Unfortunately for us, what we end up with is we end up with a we have a sound card in the machine that's going to output our audio, and what we would like to be able to do is we'd like to be able to output the audio and the video synchronously. So what we'd like to be able to do is inside any given frame boundary, we're computing the next frame. So if we are in here, if we're somewhere in here, basically we're showing some frame, and this is the next frame. Basically, we're computing a graphic, right? We're computing a little graphic here. We're trying to compute something that we're going to show right at this boundary. So this is where we're going to start displaying this to the monitor. So we're computing it, sometime in here, and we're going to try and show it here. So ideally what we would like to do is also compute the sound that goes with this frame and have it line up exactly. That's what we would like to do. Unfortunately, what we found out is that the audio latency on this particular computer anyway, it obviously is going to vary when going through direct sound. And we don't know, it might be lower if we were to try X audio. We haven't tried that yet, but we have no way of knowing until we actually try. Basically, the audio latency is on the order of 33 milliseconds itself. We took a look at the difference between what's called the play cursor and the write cursor in direct sound, and we found that basically we could expect somewhere around that 30 milliseconds of latency, which is our entire frame time, which means that assuming we're inside a frame and we're displaying something and we're computing the next one, we can't expect our audio to show up until somewhere like in here, basically. Somewhere that's like wherever we start writing it. If we write the audio here, we couldn't expect it regionally to show up at the earliest until somewhere out here, which means there's no way for us to actually compute the audio that goes with a particular frame and actually have it show up on that frame. There's really nothing we can do about it. That's just the truth. So, we've got a couple options here, and I can tell you about what they are. But none of them are great. What we may have to do is just regress to a very basic sound loop and just accept the latency and accept that it's never going to be synchronized, or we can try to do something that is synchronized on a machine that's faster.
I think on Pulse Audio, can set a pre-buffer as buffer attribute. Yeah. I've set it to default. I'm guessing you can fill the pre-buffer.
And we'll just test it somewhere there. And I don't mean faster like CPU, I mean less audio latency. But basically, if you think about what happens inside of a frame, we do have some other options that we could try to pursue. And I'll just discuss what they are briefly, and it may lead to us changing the way we do audio in our platform layer just a little bit. So basically what happens is, if we break down the time, there's inside of a given frame, let's say we're taking this frame, and we want to kind of blow this out into what is actually happening inside the frame. So we're going to divide up this time. This is our 33 milliseconds. We're going to divide up this time into what we're actually doing, right? What we're actually trying to do. What we're going to do here is the first thing we're going to do that doesn't really take a lot of time is we're going to gather input, right? We're going to gather input, okay? So we're going to get the keyboard, we're going to get the mouse if we wanted it. We're not really using that in the game, but we may use it for debug purposes. We're going to get the keyboard, which we are using for game pads, that sort of stuff. We're then going to update the game, right? So that's this. We then have some amount of time that we have to do update the game and make a render list. So we have to update and like do render prep, basically, right? And you'll see what that is kind of as we go through. But we're going to update and do render prep in here, right? Then we're going to actually have to do rendering, which is the majority, especially in this type of game where our physics, we're not doing like a 3D game, so our full 3D physics and collision detection, that sort of stuff, would normally take more time. But since it's a 2D game, we'll probably be able to keep that code pretty optimal when if we write it properly. So we're not expecting this to grow that huge. It'll be complex because I'd like to make it fairly complex, but I don't know that it'll grow that huge. It might if we start doing some things like fluid effects and stuff like that. So we can't guarantee that, but chances are, especially when we have the software renderer, this is going to be a huge amount of time. When we start using GPU, it might go down quite a bit because GPUs, especially if it's a fast GPU, will just romp through a 2D game. But you never know. We can run in 1920 by 1080 all the time, and at full multi-sample and stuff, and suck down more GPU time and stuff like that. So you never know. Point being, that takes a bunch of time, and then any time that's left over, we're just waiting, right? We're just going to wait until the flip, right? And then here we actually display the frame, right? And this can actually be pipelined to some degree. So depending on how deep the pipeline is, a pipeline is basically something where you're going to push more frames down, have frames be computed overlapped. So we could start right after we finish rendering this, or even if we were multi-threaded, we could start doing gather input and updating before we even do the rendering, right? There's a bunch of ways we could overlap this. But if we're just doing it synchronously on one processor, no overlap, then this is what that's going to look like, and then we flip, right? And certainly back in the old days, this is what it looked like because there weren't multi-core things, there wasn't a GPU, so you were just talking about this exact process: gather input, update, render, wait, flip, right? Now the question then is, where do we insert sound in all of this, right? The answer obviously would be, if we are trying to minimize our audio latency and hit this time right here, then if we have a 33 millisecond sound delay, if we have something that's close to the frame thing, then we'd actually have to start outputting the sound for the next frame. We'd have to output it like back here, right? Does that make sense?
Mm-hmm.
We'd actually have to output the sound before we even gather the input for this frame, which means that it's sort of somewhat impossible for us to do. But if you think about what was actually happening, if we go ahead and tack on basically another frame to it and look at the same thing, so basically just copy what we just drew, over here. What was this period back here that was before the thing? Well, this was the wait period, right? And then before that was the rendering period, right? So actually, all the way back to almost the beginning of this other frame, like let's say this right here is only taking 10 milliseconds, and this right here was taking 23 milliseconds, right? So we divide the frame time up, and basically the gather input and that update step is maybe only 10 milliseconds, and then we spent a lot of time rendering and waiting, probably mostly rendering. Well, that means all the way back here, if we look at what the time was, right when we actually, after we did the update, where we could have known what the sound was going to be, right, for the next frame. If we go all the way back here and look at that, if we were to sort of output the sound right here, on the previous frame, we could have been only one frame behind, right? If we did everything exactly right, we could have been only one frame behind. And furthermore, if we actually take this wait period, or if we take this render period and overlapped and started the update for the next frame here, right? So this is where the gather input happens. So we basically overlap the gather input and update for the next frame with the rendering of the previous frame. If we actually overlapped those on 2 cores, we could actually hit the constraint of being 40 milliseconds or something ahead of where we wanted to write that audio and actually get our audio synced. But there's a cost. The cost is now we have pushed input gathering back a little bit further. So we've introduced basically 23 milliseconds, somewhere around, at maximum, 23 milliseconds of input lag, right? That would be the cost. So if you think about that, is that a good trade? Probably not. For a game like this one's, audio sync is not that important because none of the gameplay really revolves around hitting a sound directly. We will probably have audio cues in the game that try to help the player understand what's going on, recharge times, whatever, enemy attacks, that sort of thing. So, audio is important in every game. I certainly don't want to suggest that it isn't, because it very much is. But how tightly the audio synced is as a priority versus how tightly the input is synced, in this game, I'm going to say that the input lag would be way worse if we did that. So I think we really want to push our gather input as far forwards as we can, and we don't want to introduce that extra lag. So, given that we don't really have any...
Interesting. Is it always trade-off? Where's my input? Yeah, I can get rid of this for now. I'll leave this on, whatever. Okay, set up the window. I call this directly here. Oh yeah, because I need to fill the buffer. I need to rename this to something else. Game update, and yeah, well, I guess that makes sense. The frame window. Okay, I see. Because then before, right, get in the event, you could here do audio. Then that means the input will be delayed. Okay, I can see that now. It's good to know.
Options, realistically, given that, for hitting our audio sync on a given frame. What I'm going to suggest is that I backpedal a little bit from what I was hoping to do, which is keep the audio and video synced to frames, and basically say, all right, we're going to go fall back to a little bit stupider, right? And what we're going to do is just say, all right, we're computing our stuff, and somewhere in here, after the update and input has happened, somewhere in here, we're going to try to write the audio. And we're just going to accept the fact that it's not going to be on a frame boundary. It's going to be basically somewhere in the middle of next frame. And we're going to accept the fact that there's basically 15 milliseconds or so on this card of audio latency, and it's going to write right into the middle. We will lie to the game. So we will tell the game that it is outputting this frame's audio. So the game doesn't have to try and account for that 15 milliseconds of lag. We won't complicate the game's code by forcing it to do that. But what we will do is we'll basically say, all right, you go ahead and output for the frame. You're actually going to be lagged by a little bit, and this is kind of a very standard audio loop. And it's unsynchronized, it's a bit sloppy, but it's better than the alternative, which is pushing it out to this frame and having one whole frame of lag, or buffering a whole frame ahead and introducing input lag. So what I'm going to try to do is basically write it, go change our audio code so that that is what we do in the case where the audio latency is greater than what we think we can achieve. In the case where it was less, like let's say we look and the audio card's got like 5 milliseconds of latency. It's like awesome. Maybe we're on a console or something and we can get that. Then what we will do in that case is we will try to make it so that it is offset, and basically we will write the audio with some buffer so that the audio for a frame does line up with the frame. So basically we're going to have basically a conditional sort of output. There will basically be one path for latent and one path for non-latent audio. And they won't really be paths, they'll just be our computation about where we're trying to hit will basically be sort of thresholded. So when we look at that lag, assuming that it's more than the some conservative estimate about where we can update our audio. Let's say that we assume that we're going to be able to update our audio 16 milliseconds into the frame or something halfway through. Then we're going to say, well, if that difference here, if the audio latency is 16 milliseconds or more, then we're basically going to have to just be writing as soon as we can. If it's less than that, let's push it up to that 16 milliseconds to try and keep it right about here. And we can even measure what our average update time is in here to try and keep that as close as possible, if that makes sense. So yeah, we can do a bunch of stuff like that to try. We'll try to do the best we can, and we'll go from there. So that's about all we've got. And I'm going to go ahead and do that. I think I mentioned on Twitter, for those of you who are following, I feel like today might be a long session. I'm going to go ahead and do this. It'll take us a little while to do because this kind of code is always very finicky, very error prone. You saw how many mistakes I already made in it, and we'll make more, I'm sure. So it's going to take us a while to kind of go through that. But if we finish that in a reasonable amount of time, I may double the length of this stream and basically do 2 hours plus. So basically what we're going to do is every time we take a look at our get current position, right? So we come in here and we take a look at get current position. The play cursor and the write cursor.
I could just go to the next day, because I think the way I mean, the Pulse Audio API is very different. At least the one that I'm using. A simple one. So I guess I want to see if there's something.
All right, so anyway, we've got those values now. So what we need to do is we need to think about when we're going to do our computation of where we want to write to. Basically, we know what our audio latency is. We know what the write cursor was, right? And so really all we have to determine is how much past the write cursor we actually want to write in terms of the sample count. So basically what's going to happen here, going back to the diagram, is we're in a situation where we've just flipped, right?
Hey Taras, how you doing?
Right. We just flipped, and when we did the flip, we're at this point in time. In fact, I can show you where we are in the code when this happens, right? We did our sleep, and by the way, that reminds me, I wanted to change this to this is not really supposed to stay in here. So log miss here. So this should actually not be an assertion because this will happen. I don't like assertions for things that actually we know are going to happen. So we need to log a miss there. It's not really. This is a missed sleep. Missed sleep here. So okay, sorry about that. Just needed. I remember things sometimes when I'm thinking about them. I remember things, and I'm like, I wanted to change that because I don't ever like asserting things that are actually going to happen. That's fine. I assert things that are going to happen when I'm testing code, but I don't like to leave those in there. The game should never assert when you're running it. That's always just a bad thing. All right. So basically what's going to happen is right here, we did our flip, Win32 display buffer window, and then we asked what the current position was. So basically we did our flip here. We asked what the current position was, and we kind of know that the play cursor is going to be so we're right here, we're here, right at the flip dime. We asked where the play cursor is, and we kind of know on this machine it's going to be like right there, right? It's going to be pretty darn close to where we were, at least what we're expecting, right? And so the right cursor is actually going to be here. The right cursor is actually going to be somewhere out in the the frame, like here. This is where the right cursor is going to be, if that makes sense. Now it could really be anywhere. I mean, we don't know that. I'm just saying, the play cursor is going to be somewhere behind where we are in theory, or close to. If we were really good, it'd be close to where we are.
Okay, I think. Let me see. Is there anything else I want to look into? Also,
But it looks like we get into certain situations like this where they're pretty far away from each other, and I don't know if that's to be expected or not. I guess there is the fact that we can have that jitter up to 480 samples. So maybe what we should do is also draw in a 480 sample window to basically say, well, it could have moved by this much. Now, if it did, though, then it would be, yeah, well, okay. Let's draw that in and just see. So we knew that there was basically a 400, when we measured this card, we knew there was a 480 sample difference there. So I'm going to say, let's go ahead and draw that in. Let's do that in our...
okay, I could just go to the next day. But there's something else I wanted to do. Since... okay, yeah, I think I know what I want to do. I want to fix the renderer. Because right now it's totally wrong. It's too... What's converting 1D to... sorry, the other way. Yeah. It's x times x plus the width times y. I think that's what I've done. I equals x plus width times y. Yep, y times window width and then plus x. Maybe I don't need this second loop. Yeah, I could just do it once. Times buffer dot window width. And get rid of this. This will become no, I think not. Yeah, let's try it. See what that looks like. That's actually closer. But like flipped. Just needs to flip it vertically. Oh no, I think I need to do what does it look like? What's with all the lines in between these lines? The audio kind of looks it looks cool. It has the same problem. I think it needs to be flipped the other way. Yeah, simpler. Hang on. If I just flip the loop. Let's make this X. I think that I. What does that look like? Interesting. So look at, here, memory. Hang on, before I do that, let me just commit. Memory, the other file. I make this a slice of U32, and then some buffer's fine. This should be slice of U32. Then the renderer. Hang on, I gotta change something. That's not correct. This is not needed. What's wrong with the audio? Okay, it's fine. It's just the beginning. I think I know why that's happening. Looks slice. Hey, Moreno Blue. Finally got you live. Okay. Yeah, I mean, I think I didn't stream for a few days either. I got the audio working finally. So it's like I deserve a couple of days break after that. X times self dot height. Height. Alright, because it's mapped to a 2D array. What am I missing? How is it arranged in memory? Is it x1, y1? Oh no, this would be one. This would be 1. And this would be 2. So if I make it one dimensional, x1, y1, 2, y3. Dot buffer dot window width. So be x. Yeah. left a moderately big comment on day 19 asking a question. Where did you leave it, Moreno? Why? Oh, okay. Yeah, just give me like 1 sec. This would be x times the window. So index equals index equals plus y. I have a feeling this is exactly like what it was before. Okay, at least something's wrong. Index out of bounds. Okay, I'll check that later. Let me have a look at. Oh yeah, I see a notification. Was this one? The first one? I mean, I don't think so. Let me check. Day 19. That's day 18. Late. I don't think I see it. Are you sure it was my video? Let's have a look. Content thing here. It's a bit warm here. It says one comment, but I can't see it. Am I looking in the wrong place? It won't show me the comment. Yeah, it says one comment, but I don't see it. I think so. See if I can refresh. Whoa. Yeah, unfortunately. You could just paste it in the chat. Yeah, then it's fine. Okay. Maybe you can just paste it into. Yeah, I mean it's fine. Why is index out of bound? Well, something bad. Oh, how big is the comment? Maybe you can paste it in. Yeah, that's fine. You can just email it to me. Yeah, that's fine. 461757. Yeah, that is way too big. Why does it go that far? Yep, will do for sure. I'll just email it back to you. Width times height. X times pixel and I need a new line. That's weird. Right, because I think it needs to be pixel index. Is it? Alright, no worries. Get some sleep. Good night, Moreno. Fuck, what goes even bigger? So index. Okay, that's definitely wrong. That should just be 479. I think I'm doing something very silly. $79. Oh, there we go. X times buffer the window. No, that's not right either. X times self dot height plus Y. What am I missing? Okay, I think this should be -4. Starts from 0. No. Okay, it goes up by a lot. Height plus y. Height comes first. X times self dot height. I would have thought it would be the other way around. Okay, that's not right. Okay, it's printing something. I don't think it's right. Something I wanted to check is why did I multiply by size of 32? 32. Interesting. If I print y, print vertical lines. If I do x times y. Okay, print some weird stuff. No, jeez. Now let's say if I wanted to add an offset. hang on. Debug sound. Comment that out. Don't need it. Say I wanted to move across. How can I make it move or appear like it's moving? Let's say I want to move it to the right. Let's see if I have an offset. Okay, I have a pitch. Do I use it? No, I don't. Okay, let's do that. Be the same, and then it will overflow at some point. Pitch plus 1 mod buffer. Zip mem. Oh, wait. Yeah. Hey, that does move. Moves in a weird way, but it moves. That's pretty cool. Now, how do I... What if I do minus? Can it be minus? To use sides, no. How do I make it move in other directions? No idea. At least it moves in one direction. That's... Oh, I know. I can map it to the key. Pitch. Let's make this... Let's make this I32. I'd have to update the window. Size memory, render game. What does this expect? Expects a U8. Bytes per line should be the screen. Buffer, the width times size of U32. Set capital. Put it back to U32 for now. Right is D. So if I press D, yeah, sure. What's the question? If there's only one question, why not? Oh, I think I missed somebody's message. Hey, Bagthug, sorry. I totally missed that one. I got the audio working. It's a bit late, but I'll answer it anyways. I got the audio working, so I'm just cleaning up some of the old to-dos. Game state. This one. Which programming language would you recommend to a complete beginner in the programming universe? I would say some high-level programming, JavaScript, Python, mainly because you can start building stuff quick, and then afterwards you can always go lower. That makes sense. Because I started with C, and I think for me it wasn't. I would have preferred a higher level. Yeah, I think that maybe, probably. Yeah, there we go. We've got two answers. What is game memory? Okay, right there. Red offset. Let's make it red. OX should be red. Should be blue. That should be green. Okay, and then I would pick JavaScript. Complete beginner. Yeah. And if you need why, because probably you can build everything with JavaScript. But I don't know. I think the question might not be like complete. Because now that I'm thinking, it also depends what you like to do when you learn in programming. Yeah, true. Because let's say someone wants to build games, like they like to build games, then in that case they should start with C. Yeah, but I don't know if I want to build games with that. I'm honest. Actually, you know what? Um, your name is quite hard. Tannaville. Tannaville. I pick C. I changed my answer. I pick C. I think start with C. I think I started with C, and I'm glad I did. Then you can pick another. Okay, on A. Dot red offset plus equals 1. Yeah, I would say start with C. Yeah, because it helps you build fundamentals. And then from there, you can just learn any language you want. Yeah, I pick C. Change my answer. Well, Taurus. I don't know what to say. RISC-V assembly language. I probably wouldn't suggest assembly. But I mean, I think at some point it's good to try. I Thanks for including us. I mean, C#'s not bad. But yeah, but I don't like it. Cool. Maybe. Does that make sense? Let's just leave it as one for now. Yeah, I do remember. And it would like crash all the time because it was an older computer too. You know, I just realized that starting from like a high level language makes it really hard to learn other languages. But the opposite is quite easy. But I mean, Taras, I think Python is the most used language right now. My renderer. No, I need the game state. RGB. Okay, it should be green second. This is wrong as well. Let's see what that looks like. '88. Expected to argument. game memory dot game state. That's it. Window width, sorry. Oh yeah. Yeah, it's gonna be white, but why does it not change colors? Let's make it 10. Yeah. I don't know what I've done, but it's not what I've intended. Colors were right. Okay, I'll just leave it x plus y for now. Okay, I think I'm gonna call it a day there. Because okay. Because I think to print vertical lines like this, not sure how to do it yet. But we'll see. I think problem for later. But that's not really a problem at the moment. Okay, start with day 21 tomorrow. That's pretty good. Already at day 21. Instantaneous live code editing. So it looks fun. Alright, I think that's gonna be it for today. I do want to try something though. See who is streaming. Hey Taras, see ya. My internet's broken. Well, never mind. Alright, I think that's gonna be it. Hope you have a good day. Have a good weekend. And I'll see you back here tomorrow. This was fun.